Now what we're looking at today is the review sheet. First two problems we have are these here, 1 and 2. We want to solve each of these for the value of x. If your answer does simplify, like 2 to the third, we have numbers that simplify and reduce, we're going to reduce them. If they don't, as in e to a power, we leave it. So these first two, 2 to the 2x plus 15 is equal to 8 to the x minus 7. With problems like these two, we want to get the bases to be the same. Now, since the one side is the base of 2, we would like to rewrite 8 as 2 to a power. It'd be 2 to the third. Now, our powers of powers multiply, so 3 times x would be 3x. 3 times negative 7 would be negative 21. And the reason we do this is because if the bases are indeed the same, like we have them now, they're both 2. If the bases are the same, the exponents have to be the same as well. Thus, it's telling us that 2x plus 15 is equal to 3x minus 21. If the bases are the same, we set the exponents equal and solve for the value of x. There's many things we can do. I'm just going to subtract 2x first because we could have subtracted 15, we could have added 21, we could have subtracted the 3x. We just need to pick one of them and do it there, because when we subtract the 2x, we get 15 is equal to x minus 21. Lastly, we can add 21 to both sides, telling us x is equal to 36. Questions on this here? The same thing is true for number 2. Now, we could change these to something lower, possibly lower than 8, but I would try 8 first. Because we can grab a calculator and say 8 to the third is indeed 512. So what that means for us is this side we can write as 8 to the third to the 5x minus 1. We can also rewrite 1/8 as 8 to a power, but it would be 8 to the negative 1. Because if we move a number from the bottom of the fraction to the top, its exponent goes from positive to negative or negative to positive. And again, our goal is to get the bases to be the same for these here. Here we would distribute. 3 times 5x is 15x. 3 times negative 1 is negative 3. We'll do the same thing with our other side. We're distributing the negative 1. Negative 1 times 4 is 4. Negative 1 times negative x is plus x. And if you're wondering when we would need to do the keep the bases be the same, especially on the test, is if there's variables in both exponents, we're getting the bases the same. If there's variables in both exponents, you're getting the bases to be the same to go from there. It is possible to do it without making the bases be the same with logarithms, but it's a lot more steps and a lot more time. Questions on this here? Bases are the same, yes? Set the exponents equal to each other. 15x minus 3 is equal to 4 plus x. Next thing we can do is add 3, yes. Negative 3 plus 3 is 0, leaving us with 15x is equal to x plus 7. Now we need to get the x's on the same side. So we would subtract x from both sides, telling us 14x is equal to 7. So divide both sides by 14, telling us x is equal to 1/2. And I still classify a fraction as a nice number. Fraction is a nice number. It is easily writable. Our non-repeating, non-terminating decimals that we get from having e to any power other than 0, or any of our logarithms where the base and what's inside are not the same, we're going to leave those as logs. We're going to leave those in exponential form. 3 to the 4th power, we're going to simplify. 3 to the 4th is 81. We can rewrite that nicely. But questions on these here? We good with these two? Let's look at number 3. E to the 4x plus 7 is equal to e to the 6x minus 35. Wait a minute. Are the bases the same? Does it matter that it's e? No. It still means that our exponents have to be equal. If the bases are the same, the exponents have to be equal. Now we just need to solve for the value of x. We can subtract 7 from both sides. Telling us that 4x is equal to 6x minus 42. Then we can subtract 6x, telling us negative 2x is equal to negative 42. Last but not least, we would divide by negative 2, telling us x is 21. Questions on this here? Questions on anything we've done so far? We ready for the next one? 2 e to the x minus 7 equals 5. Well, the bases aren't the same, and there's no way we're going to make them be the same. So what we want to do is get the term with the variable and the exponent by itself first. And we can. We'd add 7, because negative 7 plus 7 would be 0. Telling us 2 e to the x is equal to 12. What can we do next? We would divide both sides by 2. Telling us e to the x is equal to 6. Questions on how we got to this here? Okay. Now we need to get the variable out of the exponent, yes? So we would use logs. Specifically, we would take the natural log, because with e as the base, we always use the natural log, primarily because the natural log of e to the x is x is equal to the natural log of 6. Yes? Questions on how we got to this here? Questions on any of this so far? Is the natural log of 6 a nice number? That's your answer. With all of our logarithms, where the base and what's inside are not the same, or a power, natural log of e to the 3rd, where they don't simplify out, we're leaving it. X equals the natural log of 6. We are done. You do not have to convert that to a decimal. Questions on this here? I'm going to skip to number 6 real quick. Now our term, number with the variable and the exponent's already by itself, yes? What would I apply to both sides? Log base 7. And we do this because log base 7 of 7 to the x is x. On the other side, we have log base 7 of 3, yes? We're done. Log base 7 of 3 is not a nice number. Because no matter what we put 7 to, whole numbers or integers, or rational numbers, we're not going to get 3. It's going to be an irrational number. We are done. That is the final answer. Questions on this here? Do we need to look at number 5? Okay. Because again, the first thing we need to do is get e by itself. So we would subtract 9, telling us that 6e to the 2x plus 1 is equal to 6. Yep. We're going to divide both sides by 6. Telling e to the 2x plus 1 is equal to 1. Take the natural log of both sides, because ln of e to the 2x plus 1 is 2x plus 1. Natural log of 1, just for kicks, because it's not going to be a nice number. Well, it is, yes. It is. 1's the only one besides the number itself. But that's not going to show up on the test. So we have ln of 1. Now we just need to solve for x. And lastly, we would only read it was, and it worked out to be a nice numbers with, because the exponent became 0. But questions on this here? Let's look at number 7. Well, our number that has the variable in the exponent is already by itself, yes? So what are we going to do? We're going to apply log base what? 11 to both sides. Log base 11 of 11 to the 6x plus 2 to 6x plus 2. Well, log base 11 of 38 is not going to be any nice number, because 11, 121 going on. So we're going to leave it. Questions on this here? Next thing we can do is solve for x. So we would subtract 2, telling us 6x is equal to log base 11 of 38 minus 2. And lastly, we would, telling us x is equal to log base 11 of 38 minus 2 all over 6. That's it. Any questions on 1 through 7 so far? We're ready for number 8. Natural log of 3x plus 2 is equal to the natural log of 4x minus 5. One-to-one property. They both are logarithms and they are the same log, yes? So what's inside must be the same. So 3x plus 2 is equal to 4x minus 5. Yes, we can subtract 2 from both sides. Telling us 3x is equal to 4x minus 7. Well, wrong color, but we'd subtract 4x. 3x minus 4x is negative x, is equal to negative 7. Now we can divide by negative 1, or we can multiply by negative 1. Either one will give us the same thing, because negative x times negative 1 would be x. Negative x divided by negative 1 is still x. And 7 divided by negative 1 is 7. Multiplying or dividing by -1 will give us the same result. Questions on this here? Number 9. Log of 12x minus 9 is equal to log of 3x. Since the logs are the same, we set them equal to each other and solve. Well, different ways we can do this. We could have added 9 first. We could subtract 3x. I would just subtract the 12x as much as I don't like the variable being negative. But if I do that one move, we're saying that -9 is equal to -9x. Numbers on one side, variables on the other. At this point here, we can divide both sides by -9, telling us x is equal to 1. That's it. X squared minus x minus 6 equals -x. So, on color. We can add x to both sides, yes? Telling us x squared minus 6 is equal to 0. We'll give it a minute to wake up. Because the one thing we can do is graph it, because we do have a quadratic. Y equals, clear that out, x squared minus 6. Graph. Well, it does cross the x-axis at 2 points, yes? Or either one of them a nice number? No. Now we could factor it, but do we have an x term? Do we have a middle term? No. So what I can do is use the square root method. Telling us x squared is equal to 6, yes? And lastly, we can square both sides, telling us x is equal to plus or minus the square root of 6. Now we do have to be careful with some of these here, especially with our logarithm, because our negative x is by itself, yes? So if I look at it, negative x, well, we have two answers. We have positive square root of 6, yes? Well, negative positive square root of 6 is negative square root of 6. So it's telling us with positive square root of 6, what we have left is log base 2 of negative square root of 6. We cannot have a negative inside the log, so our positive case is out. It doesn't work. Let's look at the negative case. Negative negative square root of 6 is the square root of 6, yes? So the actual answer is not, it is plus or minus when we solve, but the actual answer that we want is just the negative square root of 6. Does that make sense? And I put that one in there on purpose because I wanted to show you guys one where the negative case was actually the answer, not just the positive. But in most cases, we end up throwing the negative out. That it would have just been the square root of 6, not negative square root of 6. But questions on this here? Most of the ones on the test, the answer just works, like number 9. Okay? And again, like always, there is no solutions on the test. I do not put no solutions on the test. So any questions on 1 through 10? So, number 11, log base 7 of 4x plus 9 is equal to 2. Now when we solve these, the first thing we want to do is get the log by itself and only have one of them on one side. Well, we're already there, yes? Now since we're starting out as a log, we're going to put both sides to a base, and the base in this case would be 7. 7 to the log base 7 of 4x plus 9 is 4x plus 9. Is 7 squared a nice number? Yeah. It's 49. we're going to simplify those. We are going to get an answer. We're not going to have log or exponentials left over. Now we just need to solve for x. Subtract 9. 4x is equal to 40. Divide by 4. Because if you have log with a base or just log, we're going to get a precise answer. Because it's a number to a power, yes? Natural logs, we are not. Because if we look at the next one, 12, ln of 6x minus 2 is equal to 7. Log's already by itself. Now we're going to put both sides to the base of what? E. Because the natural log is e. E and our ln would cancel. Ln of 6x minus 2 is equal to e to the 7th. E is irrational. So no matter how many times we multiply it by itself, it's still going to be irrational. It's just not going to magically turn rational, no matter what we do. So, are we going to get a nice answer for this one? No. So that means we're going to leave it in exponential form. So we're going to add 2. Telling us 6x is equal to e to the 7th plus 2. Divide by 6, telling us x is equal to e to the 7th plus 2 all over 6. Questions on this here? $11, we got a nice answer. $12, we did not. E to a power. Leave it. $13 is the log by itself. Well, yes, and there's only one of them, so we can put both sides to the base of 9. So it tells us 2x plus 7 is equal to 9 to the 2nd power, or 81. Now solving for x, we would minus 7. Telling us 2x is equal to, I believe, 74, yes? And lastly, we would divide by 2, telling us x is 37. Questions on this here? We ready for the next one? So we're good with everything so far, yes? 14, ln of 6x minus 4 is equal to 15. Is the log by itself? Because if the minus 4 was inside the parentheses, then yes, it would be by itself. But since the minus 4 is outside, we have to move it first by adding 4. Telling us the natural log of 6x is equal to 19. Now it is indeed by itself, so we would do what? Put both sides to the base of e, because e and our ln would cancel. Telling us 6x is equal to e to the 19th. E to the 19th does not reduce nicely, so we'll leave it. And we do have one last step. Divide by 6, telling us x is equal to e to the 19th over 6. Questions on this here? Let's look at 15. Whenever we have more than one log being added together, we can rewrite them as a single log with what's inside being multiplied together. We can take two logs, two of the same log, and rewrite it as a single log with what's inside being multiplied together. Questions on how we did this here? Now to solve, we're going to do what? Put both sides to the base of 2. Because our 2 to the log base 2 will cancel, leaving us with x plus 4 times x plus 1 is equal to 2 to the second power, 2 squared, or we can just say that that is 4. Now rewriting it as 2 squared is not wrong, because we will need to simplify it eventually, but we can do it now or later. Now we do need to distribute over here. X times x is x squared. X times 1 is plus x. 4 times x is plus 4x, and 4 times 1 is plus 4 is equal to 4. Combine like terms. X plus 4x is 5x. Now we do have a quadratic, so we need to get this equal to 0. Telling us x squared plus 5x is equal to 0. Questions on how we got to this point here? Now there's two ways, there's several ways we can go about this. One of them is graphing. X squared plus 5x, graph. It intersects the x-axis at 2 points, and they are nice points, yes? Second graph. We have -5 and 0. So these here are our two solutions. Now I wrote those two out specifically because those are the two expressions that were inside the logarithms, yes? The expressions inside the logarithm cannot be 0 or negative as their final result. Not what we're plugging in, but the final result. So, if I try -5 first, -5 plus 4 is -1. Does it matter what the other one gives us? No, because it's negative. One of them's negative. It's immediately out. If we look at -5 plus 1, we get -4. So it tells us that x is equal to -5 does not work. We could type the whole thing in, log base 2 of -5 plus 4, and do it all the way through. It would just tell us domain error. It will tell us error, it doesn't work. We can check with 0. 0 plus 4 is 4. 0 plus 1 is 1. That works. Because even though x is 0, when we plug it into each of the expressions, we get a number that is not 0 or negative. So x equals 0 works. Question? Because the x value that we got for the solutions, one of them was -5. That's our solution. So I went back to the top here. And in both of these places, I plugged that value in for x. So -5 plus 4. Well, -5 here and here. Because what it told us is that we have log base 2 of -1 plus log base 2 of -4. When we plug it back in, I didn't write the whole thing out. But when I did -5 plus 4, it gave us a -1. -5 plus 1 gave us -4. The number that ends up being here when we plug in the value of x cannot be negative or 0. If it's negative or 0, it's immediately wrong. It doesn't work. So we threw -5 out. And instead of rewriting log base 2 of -5 plus 4, in parentheses, plus log base 2 of -5 plus 1, and then rewriting it out as log base 2 of -1 plus log base 2 of -4. I'm cutting that all out because really all that matters is that x plus 4 and x plus 1 cannot be negative or 0. So that's all I looked at. -5 plus 4 is -1. -5 plus 1 is -4. Either one of them gave me a negative, so the answer is automatically gone. So this is just a, here is just a simplified version of doing a full-on check. Because our main concern is that what's inside the logarithm, when we simplify, when we plug it back in and get it down to our number, it's not 0 or negative. Because if it is, it doesn't work. Because log base 2 of 4 plus log base 2 of 1. Well, log base 2 of 4 is 2. Log base 2 of 1, as we saw as natural log of 1 earlier, was 0. So 2 plus 0 is indeed 2. It works. Does that make sense? So I would be making sure, especially if we have it set up as 2 logs being added, there is one of them like that on the test. Check and make sure that which ones work. It will be the case that one of them does work, the other one doesn't. It will not be the case, especially on the test, that you throw both out, okay? Because if you threw out all the solutions, it ends up being no solution, and there are not any no solutions on the test. I'm just not going to do that to you. Let's look at one more. Because if we look at this next one, log base 2 of x plus log base 2 of x minus 2 is equal to 3. Now, whatever the value of x is, it cannot make our first one with x or the x minus 2 be 0 or negative. If we have that, we have to throw those out. But we can worry about that later. Now, since I have 2 logs with the same base being added together, we can rewrite it as a single log with what's inside being multiplied. So our x and x minus 2. I erased the 2 because I accidentally tried to write a 3. Then wrote a 2 over the top of it. Didn't like how it looked. Questions on this here? Now it's just the same as what we've been doing before. We're going to put both sides to the base of 2. Because our 2 to the log base 2 would cancel, telling us that we have x times x minus 2 is equal to 2 to the third, and 2 to the third power is indeed 8. Bless you. Questions on how we got to this point here. Now on the left-hand side, we can distribute. X times x is x squared. X times negative 2 is negative 2x is equal to 8. And we would, bless you, minus 8, telling us x squared minus 2x minus 8 is equal to 0. Squared minus 2x minus 8 graph. 2 points. Yes, negative 2 and 4, because when we graph it, we're looking for what values x of x make the y value be 0, negative 2 and 4. We got 2 answers, so it might be helpful to check. Our 2 expressions were x and x minus 2, yes? Well, if I check with our first solution of negative 2, that'd be negative 2. Negative 2 minus 2 is negative 4. They're both negative, so we know that x equals negative 2 is gone. If we try 4, replace it for x, it's just, well, 4. Only value for that there. 4 minus 2 is 2. Both of them are positive and not 0, so x is equal to 4. And all we're doing is plugging them back in to make sure that they are not negative or 0. If it's just x, like we had log base 2 of x, the negative case is immediately gone because there's no way to offset that negative. There's no way in the equation to make that negative positive. Questions on this here? We'll finish this up tomorrow, and your test will be Wednesday. I was planning on it being tomorrow, but it will be Wednesday, and y'all will be able, I highly believe that y'all will be able to do this in one day. Take the test. Because again, it's taking me more time to explain it than it is to actually solve most of these here. Would y'all agree with that? Yeah. So